Radiological effects of depleted uranium ammunition. First of all, what is depleted uranium? Natural uranium contains three uranium isotopes mixed together: uranium-234, 235, and 238. Depleted uranium, or DU for short, is uranium containing high amounts of uranium-238 and lower amounts of other isotopes. More exactly, it is uranium containing less than 0.711% of uranium-235 by weight. It's a byproduct of the enrichment process used to make reactor-grade uranium. Because of the different percentages of uranium isotopes in depleted uranium, its specific radiation activity is approximately 40% lower than that of natural uranium and considerably lower than that of enriched uranium. Uranium is 65% more dense than lead, with density of 18.9 grams per centimeter cubic, has a high melting point of 1132 degrees Celsius, and is highly pyrophoric, which means it ignites when it fragments. These properties make it suitable to use for tank armor and ammunition. Now let's talk about radiological effects. Uranium is an alpha particle emitter, but beta and gamma radiation is generated by the radioactive decay of trace levels of uranium daughter products. It has been estimated that the exposure of individuals who were inside Abrams M1A1 tank when a single DU penetrator entered the crew compartment would be approximately 4.8 millisieverts for a 15-minute exposure. So, is it a lot or little? Radiation dose limit for the generic public is 1 millisievert per year, which is lower than the received dose. But for acute radiation illness, you need to get 1000 millisievert, which is much higher than the received dose. One other fact, holding a spent DU penetrator, meaning DU metal without shielding, would deliver a skin dose of beta and gamma radiation of approximately 2 millisieverts per hour. How much is this? The current occupational exposure radiation dose limit for skin is 500 millisieverts. To receive such a dose, you will need to hold the penetrator for 250 hours. And what about health effects? There is insufficient evidence to determine whether an association does or does not exist between exposure to uranium and different types of cancer and diseases. That's all. Thank you for watching. If you liked the video, subscribe to the channel.